All right, we're going to be doing numerical integration on my kind of cheesy note card here. No one can find the note card. Nobody can find it. So I just had to make one up. Just work with me. All right, we're going to approximate this integral with 3 equal subintervals given the specified method, and we're going to state if it's over or an under approximation. Okay, so for part A, we're going to do a left RAM. Left rectangular approximation method. All right, we have 3 subintervals. So the change in x is going to go from b to a to b, 12 minus 0 over 3 subintervals. And the width of each of them is going to be 4. It's probably going to be helpful to do a t-chart. Okay, we're not given tabular data. We could produce a set of points, but we might as well just work with the data table. All right, our interval starts at 0 along the x-axis. Okay, we skip over 4 spaces. We're at 4. We skip over 4 more. We're at 8. We end at 12. So that would give us the 3 subintervals. Evaluating the function at each of these, I'm going to have 3, 19, 67, and 147. So the graph gets kind of steep pretty quickly. All right, for a left RAM, we need the area formula for a rectangle, and we're going to find 3 of the rectangular areas and add them together. All right, well, the width of each of them is going to be 4. Okay, and I'm actually going to factor it out since it's equal. All right, and then between the y value at 0 and 4, I need to choose the 3 because that's the left side. So I'm going to have 3, 19, and 67. So with the left RAM, you use all the values except for the last one. I went ahead and performed the calculation, so we got 356. All right, now we're going to state if this is an over or an under approximation. Well, remember you're doing left rectangles on an increasing curve. So just a real quick sketch of that. If you're talking about this quadratic, let's get a visual here. If you're doing left rectangles on a quadratic, your rectangles are going to fall below that increasing curve. So you have an underestimate. So you'd want to state that. Underestimate, justify, underestimate because left endpoints increasing curve. All right, and the more important thing to say here is because it's an increasing curve. They know it's left endpoints because they told you to use a left endpoint. Increasing function. Part B, we're going to do a right RAM. So we're going to use the same data table. All right, so for a right RAM, each of the 3 rectangles are still 4 wide. Okay, but now instead of starting with 3, I'm going to use the right endpoint of 19, and I'm going to conclude at 147. Performing the computations, I got a much larger estimate of 932. It's an overestimate. Because the function's increasing, I'm using right endpoints on an increasing function. All right, go back to the graph and try and get a visual of that. Again, same graph here, but now instead we're using right endpoints. So I'm going to go to the right side of the graph, go over, right side of the graph, go over. Okay, we're getting too much area. It's an overestimate. Okay, next one we're going to do a midpoint. All right, for this approximation method, I'm going to do an additional t-chart down here because we need some more information. Okay, we had the value 0, 3, and then we had 4 was next. But if we're going to use a midpoint, we can't use a 3, we can't use a 19. We need to use a value halfway between 0 and 4. So I'm going to put 2 here. Yep. And plug that in, and I'm going to get 7. All right, and then we had what, 4, and then we had 8. And that was 67. And then we had 12, which gave us 147. So I need some midpoints in here. All right, between 4 and 8, I'm going to use the y value at 6. So I think that's going to be 39. And halfway between 8 and 12, I need 10, and that y value is going to be 103. That was 10. Okay, so I had to do a little additional work to get what we need for the midpoint RAM. Okay, but again, still, the 3 rectangles are 4 wide. Okay, I'm not using 3 or 19. I'm just now using the values 7, 39, and 103. And as you might imagine, the midpoint rectangles are going to be a better approximate. Performing the calculations on that, we got 644, which seems nicer between the 2 previous ones. And I don't want to linger about why this is an over or an underestimate, because typically when they ask you that question, it's with regard to a left or a right, okay, and sometimes a trapezoid. Okay. It is an overestimate. That graph is concave up with midpoint rectangles, so there's going to be a lot of area. Pardon me, it's an underestimate. I'm looking at the trapezoid. It's an underestimate. There's going to be a lot of area that's not accumulated. It's an underestimate. Again, like I said, I'm not going to linger here. I've never ever seen a midpoint question with coupled with, is it an over or an underestimate? It's just too hard to tell. Okay, let's look at the trapezoid technique. All right, we need 3 trapezoids. Okay, I'm just going to build 3 fractions. I can factor out a half from all 3 of them, that's fine, but I don't know. For the trapezoid, I just like working with it this way. For the trapezoid formula, I need to know the height. Well, the height, because they're equal, will be 4. And I have to sum the bases. So if the heights were different, of course the 4s would be different here. So go back to the data table. What you have in black here was the original data, so those are the bases. So I'm going to add the data points that are in black here. The red was the midpoint. And then 67 plus 147. Okay, when I do all the calculations, I get 644. So let me come back up here and say, now I'm noticing that as I'm looking from the paper onto the computer screen that this value, maybe you noticed it earlier, is not correct. I'm looking at the trapezoid. You need to put a ruler down or something. It's 596. All right, so the question here is very applicable. Is the trapezoid method an over or an under? All right, well, think about this graph. It's concave up, x squared plus 3, the function we're working with. And if we're going to put trapezoids in here, the tops of the trapezoids are going to fall above the curve, just the way the curve's bending. So with trapezoids, it's all about the concavity. So you would say an overestimate if asked to justify because the graph is concave up. Overestimate because f of x is concave up. If the graph had been concave down, then the tops of my trapezoids would fall under the curve, being an under approximate. I encourage you to draw a graph if need be. Okay, Now, going over to question 2. All right, so you've got your data table. It's in front of you. I'm supposed to approximate the value of this integral with first a midpoint RAM with 3 even subintervals. So I'm going to find the width of each of the rectangles. So delta x is equal to b minus a divided by 3. So 6 divided by 3, they're 2. Each rectangle is 2 wide. All right, so looking at the data table, the first y value we're going to choose occurs halfway between -1 and 1. So we're going to use 6. The next interval horizontally is going to go from 1 to 3. We don't want to use the y values at 1 or 3. We're going to pick up the 1. And the last y value would be the y value at 4 because 4 falls nicely between 3 and 5. So that would be 8. And that 1 needs to come back. Okay. So it looks like it's 30. Okay, now let's do a right RAM. Oh, but now it tells us to use 3 uneven subintervals. And it tells us the first one goes from -1 to 1. So that's a distance of 2. The second subinterval goes from 1 to 4, so that horizontal distance between those two numbers is 3. And the next rectangle is only 1 wide, as indicated by the difference between 4 and 5. Okay. So I can't factor out that common interval. So, all right, looking at the data, between -1 and 1 is 2 wide. I'm doing a right RAM. I use the y value at 1, which is 5. So that's the area in the first rectangle. Second rectangle is 3 wide. Use the y value at 4, which is 8. The last rectangle is 1 wide, and I'm using a y value of 3. Performing the computations, you get 37. All right, and for the trap method, we're going to use 3 trapezoids to help us estimate. I'm just going to set up 3 formulas. Okay, and then unlike the trapezoidal method on the left side here of the page, these are unequal. But they're the same widths as what they were for the right RAM. So I'm going to use 2, find the sum of the bases, 3, sum of the bases, and the 1. That's a 1. So looking through the data at -1 and 1, I'm going to add 10 and 5. Looking up to the data from 1 to 4, I'm going to use 5 and 8. And the last data I'm going to use is 8 and 3. Looks like I'm going to have, it's 15, plus 39 halves, plus, looks like 11 halves. And these will collect to 50 halves. Oh, that's nice. That's 25. So it looks like my approximation using the trapezoidal method is 40. And that's probably going to be the most exact, closer to the actual. So a review of the RAMs and the trapezoidal method.